In section 3.1, we've been learning how to graph quadratic functions. One of the most important features of the graph of a quadratic is the vertex. And so we've spent some time learning how to find the vertex of a quadratic function. In a previous video, we learned that if the function is given in standard form, ax squared plus bx plus c, then the x-coordinate of the vertex can be found with a little formula x equals negative b over 2a. And so I wanted to take a minute and explain why this is the case. I've started out with the graph of an arbitrary quadratic function, right? Here's a parabola with vertex and two x-intercepts, and it happens to open, this parabola happens to open up. And what we want to do is we want to start by finding the x-intercepts for this quadratic. So if we're going to find the x-intercepts, then we need to solve the equation ax squared plus bx plus c equals 0, right? Because what we did is we set y equal to 0, and so f of x is the same as y is 0, gives us ax squared plus bx plus c equals 0. To solve this equation for x, all we have to do is apply the quadratic formula, and we get our answer in one step. The answer is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so those are the locations of the x-intercepts on the graph. One x-intercept is at negative b plus the square root over 2a, and the other x-intercept is at negative b minus the square root over 2a. So let's go ahead and label them on the graph. Now, if you think about it, adding the square root would give you a larger number, and subtracting the square root would give you a smaller number. So the larger x values are to the right, and so the value of the x-intercept here is negative b plus the square root of b squared minus 4ac all over 2a. And over on the left, the value is negative b minus the square root of b squared minus 4ac all over 2a. And so then we're going to make use of the symmetry of a parabola. You notice the vertex is on the axis of symmetry. It's exactly halfway in between the two x-intercepts. So we're only looking in the x direction now. I know the vertex sits down below, but we're not worried about that. We're only worried about the x coordinate of these 3 points. The x-intercept on the left, the x-intercept on the right, and then the vertex whose x-intercept is exactly halfway in between. Well, how do you find the number that's halfway in between two given numbers? Well, that's just the average. That's just finding the average of two numbers. We add the two numbers together and we divide by 2. So let's do that. So we have our two numbers, and we're going to add them together and divide by 2. And I claim that that will give us the x-coordinate of the vertex. This is a rather complicated expression we need to simplify. It's really not too bad if we disregard the 2 down at the bottom and we just work on the two fractions up above. They have a common denominator of 2a, and so we can just add the numerators together. You have minus the square root of b squared minus 4ac plus the square root of b squared minus 4ac. So they cancel out. and then we just have minus b plus minus b, or minus 2b. So we're going to get x equals minus 2b over the common denominator 2a, all divided by the 2 underneath. And we can simplify that a little bit. Dividing by 2 is the same as multiplying by a half. And so now we've got rid of the complex fraction. We can go ahead and cancel the common factor of 2 in the numerator and denominator and multiply across. Negative b times 1 gives you negative b, and a times 2 gives you 2a, which is exactly the formula that we were looking for.